In this video, we'll talk about how to find the expected value and standard error when we're discussing percentages. So we'll look at the question. A census of a town revealed that 60% of adults were high school graduates. A survey of 900 adults was conducted within this town. What is the chances that the percentage of high school graduates is between 58% and 62%? First, let's construct a box model. We'll have 1 represent high school graduates, and 0 to represent people who are not high school graduates. Then, while we don't know how many people are in the box, we know that 60% of the box is 1s and 40% of the box is 0s, because the percentages should add up to 100. It may be surprising to realize that this is enough information to answer this question. The number of draws from the box is 900 because that is the sample size. Next, we want to figure out the expected value. Here we're answering in percentages, so what percentage of the sample do you expect to be 1s? Well, we would expect it to look something like the population, like the contents of our box. So the expected value is 60%. Next, we want to calculate the standard error. For percents. The formula is the square root of the number of draws times the SD of the box divided by the number of draws times 100%. There is an alternative formula. It will give you the exact same answer, and it is the SD of the box divided by the number of draws. Square root of number of draws times 100%. We will use the second formula because it requires less plugging into the calculator. Let's first find the SD of the box. We'll use the shortcut, so that's big number minus small number times the square root of the chances of drawing the big number times the chances of drawing the small number. In this case, the big number is 1, the small number is 0, and the chances are the percentages of numbers in the box. So since 60% of the box is 1, the chance of drawing a 1 is 0.6. So here, make sure you're using decimals. The chance of drawing a 0, well, that's 40%, but we want to write that in decimal format, so that is 0.4. So this is 1 times the square root of 0.6 times 0.4. Let's plug that into the calculator. Take the square root. Let me try again. 0.6 times 0.4, and then we take the square root. Nope. Each calculator is a little different, so we have 0.6 times, clear all, clear, parentheses 0.6 times 0.4, close parentheses is 0.24, then we take the square root. So our answer is 0.489 We don't have to go out to that many decimal places, but I wanted to go out that far to be accurate as possible. So that's the SD of the box. We still gotta find the SE. So we take our answer, 0.489898, divide by the number of draws, that's the square root of sample size, which is 900, times 100. The square root of 900 is 30. Let's go ahead and plug that into the calculator. We divide by 30. And let's multiply by 100. And our answer is 1.63%. So we got the expected value, we got the standard error. Our problem, though, asks us to find the chances that the percentage in the sample of ones is between 58% and 62%. So here we're using normal approximation. Just ignore this question over here. That'll be for the next video. Let's see, what was it again? Between 58 and 62. The center is the expected value of 60. So we're looking for this area here. We convert to standard units. So the 60 goes to 0. 58 minus 60 divided by 1.63 is, let's use the calculator. Minus 60 divided by 1.63 is negative 1.23, and 62 will be the positive of that. So we're looking for the area under the normal curve between negative 1.23 and 1.23. Go to the normal curve table, look for z equals 1.23 or the closest one, which would be 1.25, so our answer is 78.87%. What that represents is the chances that the percentage of ones, the percentage of high school graduates in the sample is between 58% and 62%. If you have any questions about this example, please ask in the questions and answers discussion board.